Okay. Incorporating renewable energy sources into electric vehicles. Now, that sounds very interesting because I see some vehicles with the solar roof, but that's it.
Yeah, that's right. The whole deal with our project is we know that solar is not available during the night, and during shady days it's not fully available. So what we're trying to do is have redundant sources of energy to charge the electric vehicle so that more power that's wasted can be utilized to charge the vehicle. So it can extend the range of the vehicle over 200 kilometers on average on an electric vehicle in a single charge.
And the way you're accomplishing it is, it looks like you have a solar roof. Again, this is a demo, and
So
we have
wind
figures.
turbines over here that'll simulate on a large scale, but we don't on a small scale. So what this happens is as wind comes through, so we're using compressed air to simulate that. So as you have the wind turbines coming in, they generate some electricity. It's stored in the cap. And if you look onto the GUI, you'll see some values up there.
That's how much voltage is stored into the capacitor.
This much?
Yeah, we have a capacitor there just to hold the charge.
And what's the units over here?
It's in voltage.
Voltage. So I'll generate it just 11 volts just from that.
Yeah, the capacitor is actually holding that value.
Now, if you look with the heat gun as well.
See, the voltage is rising. You want to cool the bottom?
No, don't do that. Upright.
So these would be components on cars, thermal components that would heat up. And it causes increase right over here, thermoelectric module.
Right now in our model, it doesn't seem like it's much, but in a real car, it would generate substantial amounts of voltage and current.
And you have the photovoltaic model, which already is active, and PA is a source. That's interesting because that's very unconventional to have like PA as sources. So you're planning to harness electricity from vibrations.
That's right.
Look here. Watch this.
Yep, I'm watching. I'm right here.
It generates a little bit of electricity. Yeah. You get about a volt or so. You get about 2 volts roughly. You can generate up to 7 volts depending on the pressure you apply to it.
That would be great for like SUVs that are meant for rugged conditions, right?
Or even just everyday cars.
How long have you known the bike?
What?
How long have you known the bike?
So again, I mean, all these sources have to be optimized in an electric vehicle to be utilized as efficient as possible. What we're showing here is very small scale implementation, and
It's a prototype of
Exactly.
what is to come.
exactly. So I mean, the values that you get here is not as it won't replicate this in the real car, but it's a small scale model. So
Perfect.
These are the pieces that are inside the actual bike tire. So you can see, these are the things.
Yeah.
This surface right here is the thing that actually generates the electricity.
As you vibrate, then it will
As you
generate
put pressure
electricity.
and frequency with it as well. So.
Wow. Now I'll ask about some technical challenges you had because I see you're using National Instruments,
Yes.
UI.
Yeah.
You're having some boards over here.
That's right.
Components. Explain to me what is being used for what, briefly.
Okay, so we have individual sources here. Some of them are AC, some of them are DC. And the AC sources are rectified so that they become DC to charge the DC battery. And there's a summing circuit right here where all the sources are summed together, fed to the battery to charge it continuously. As you can see here, what we have here is a buffer circuit where all the inputs that are going into the Arduino microcontroller are pretty much isolated from the actual charging, so that and also it provides a high impedance input so that majority of the values that are coming in are not off going into the thing. So what we did here is we scaled the actual voltage coming in to the microcontroller because the Arduino microcontroller can only handle 5 volts. So we divided by a factor of 4 with the resistive divider there. And here what we did in software, using the LabVIEW interface for Arduino, we scaled the value back up by 4 so that it replicates the actual voltage going into the battery itself. Here we don't show too much of the current because it's very small in milliamps.
Mostly voltage signals, that's what.
Yes, that's exactly it. So it's very small, the current going into the battery right now, but in a real car, it would be in amps, not in milliamps, because the source's contribution will be a lot more.
Perfect, because in a real car, it's going in,
That's right.
80 kilometer per hour, 100 kilometer per hour.
Not 5 meters per second.
Absolutely, I agree. This is awesome.
We're actually providing for the buffer circuit to work VCC input. That's the only thing this is just a proof of concept, so it's not actually a replica of the real world.
Perfect. Again, best wishes for the judging scheme, which is coming up, I think, in an hour. You have a beautiful poster, and this is something I wonder, why is it not implemented in this industry? I'm sure something's fishy, but I don't have answers to them.
No, I don't have an answer to you either.
Again, thank you.
Yeah, no problem.